In 1880s or the late 19th century, German industry was producing a lot of electric light bulbs. But at that time, there was no standard set to measure quality of artificial lights. So they turned to Max Planck to set a quality standard and also to make light bulbs more efficient and affordable for the masses. To understand what Max Planck was working on and how quantum physics was born, we need to go through the following questions in reverse order. What is energy? Scientists define energy as an ability to do work, but this definition is not very intuitive. We can think of energy as something that is required to perform activities such as running, driving, talking, and so on. It is just like a fuel which is required to move a vehicle forward. We can gain energy by eating. Similarly, we can lose it by doing activities. There are different types of energy such as kinetic energy, thermal energy, and so on. We would be concentrating on electromagnetic energy. What is light? Light is a form of energy also known as electromagnetic radiation. It is a combination of electric and magnetic waves. We observe light in our everyday life, and this is how we can see things in our world. Light falls into two categories: visible light and invisible light. Visible light are the one which could be perceived by human eyes, whereas invisible light cannot be perceived by human eyes. Now, why it is so? To understand this, we need to go through the next question. What is electromagnetic spectrum? Light waves can be measured using wavelength, which is basically a distance between two peak points of a wave. Electromagnetic spectrum shows an entire distribution of electromagnetic radiation, that is light, based on wavelengths. Light waves having very large wavelengths are known as infrared waves, whereas light waves having very short wavelengths are known as ultraviolet waves. Human eyes can only see light waves having wavelengths between 380 and 700 nanometer. This is because of the evolution of human eyes that we can see only a specific range of light, also known as visible light. Now, since we understand what is energy, light, and electromagnetic spectrum, let us move on to the next very important question. What is ultraviolet catastrophe? When an object is heated, it radiates energy, or we can also say that it releases energy in the form of light and heat. We would be concentrating on light radiation. Depending upon the temperature at which an object is heated, it radiates certain color of light. For example, when a steel is heated, it glows in different colors starting from red to orange to bluish white. Classical physicists assume that if the temperature of an object would keep on increasing, its light radiation would also keep on increasing forever. But they were wrong. Let us again go back to the steel example. Hot steel would first glow red and eventually bluish white, which are visible lights and fall under visible light range of the electromagnetic spectrum. Hot steel would never radiate ultraviolet radiation. If that would have been the case, then steel would have become invisible, since ultraviolet radiation is not visible to the human eyes. Since the prediction went wrong for ultraviolet radiation, this phenomena was called as ultraviolet catastrophe. This was very baffling for the scientists at that time. Max Planck struggled for almost 5 years to find a solution for this problem. He tried many things but couldn't find a concrete solution until one day he accidentally discovered that energy is radiated in discrete amounts, which he called as quanta. Previously, everyone believed that energy radiation is continuous, but that was not the case, and even Max Planck did not know why energy was quantized. Since he couldn't find any other solution, and as he was desperate for a solution from past 5 years, he called this an act of desperation and thought to find a proper solution later on. Nobody took energy quantization very seriously until 5 years later. Albert Einstein released a paper on the photoelectric effect based on a solution derived from Max Planck quanta theory of energy. This was later called as quantum mechanics, which was inspired from Max Planck quanta, and the goal was to study fundamental particles such as electron or photons. This was a brief history of quantum physics, and in next videos we would go through quantum principles such as superposition and entanglement. But before we end this video, we have a very special guest, Albert Einstein. I want to thank you for your contribution in science and in quantum physics. We would take it forward from here.
Yeah, okay.